In this video, we'll look at how to determine the exact value of trig functions in radians. I strongly recommend that you're familiar with how to do this work in degrees. There's another video, determine the exact value of trig functions, which without the word radians, which is just covering the same questions. They're exactly the same two questions, only here I'm working in radians. Let's get started. It's the same work, which is begin with a sketch of the x and y axis, but you got to be familiar with radians this time. Start with your initial arm, and this time rotate 11 pi over 6. Well, 12 pi over 6 would be 2 pi, a full circle. So 11 pi over 6 is just pi over 6 short of a full circle, which means end up in quadrant 4. I'll rotate around here. Let's label that 11 pi over 6, but just short of a full circle in quadrant 4. Let's call this related acute angle beta. And now we have to solve for beta. So what's the angle to the x-axis if you rotate 11 pi over 6? Well, a full circle would be 2 pi. So beta is just going to be the full circle. Take away what you've rotated. It's whatever's left over from a full circle, 2 pi, minus 11 pi over 6. Let's make them both out of 6, so common denominator. What out of 6 makes 2 pi? Or you want to make 2 pi out of 6, so you need a 12 on top here. And note that 12 pi over 6 is still 2 pi. Take away 11 pi over 6. You get pi over 6. So the angle in here, the beta, is pi over 6. Need a special triangle to get an exact value. In radians, the angle up here, pi over 6, that's the small one, 30 degrees. So this is 1. Pi over 3, that's the big one, 60 degrees. So this is root 3 and a 2. So how do you get, let's rewrite the original equation. Sine of 11 pi over 6 is the same as its related acute angle, except for one thing. We got to check the cast rule. In quadrant 4, only cosine's positive, not sine. So in order for this rotation sine to be equal to this related acute sine, we need to make it negative to account for in quadrant 4, sine is negative. Okay, now we just need to use this special triangle, figure out what's the sine of pi over 6. Sine of pi over 6 is opposite over 2, the hypotenuse. So you get negative a half. And there, using radians, we got the answer to this question. How about question 2? Start the same way as doing it in degrees with a sketch. Label the arrows in the x and y axis. Put your initial arm, clearly labeled. And then where is cosine negative? Well, the cast rule, which you write like so. Everything's positive in quadrant 1, but cosine is negative in quadrant 2 and in quadrant 3. So let's call this first rotation theta 1 and this second rotation theta 2. And let's put betas here and here. So two possible answers could be in this quadrant, that's the first answer, or in this quadrant, that's the second answer. And we're going to find the related acute angle, they're the same for both, to the x-axis. Related acute angle, which I'm calling beta again. But we have to solve it a bit of a different way. That is, we have an equation here. Oh, we're not going to write it quite like this. We have an equation here, but we're going to solve for the beta inside these triangles. I'm drawing them faintly just so you can visualize that I want to solve this angle in the triangle, which means it's going to have the same fraction, cos of beta equals root 3 over 2, but it's not negative, it's positive. In a triangle, you can't have negatives, it's sides. Sides can't be negative, they're always positive numbers. So this angle will determine using this formula, but using the positive version. That is, we're going to solve beta is the inverse of cos. How do you get rid of cos? Inverse cos of root 3 over 2. You could do that on your calculator if you didn't want the exact value. We do. So how do you get the exact value of root 3 over 2? You look at the special triangle and say, where is cosine's inverse? So where's adjacent and hypotenuse root 3 over 2? This special triangle. So which one has adjacent of root 3? pi over 6. If you choose pi over 6, you get adjacent, root 3, and hypotenuse, 2, which is what we want. So the related acute angle is pi over 6. But we're not done. All we know is the angle in the triangle is pi over 6. What we want is theta 1, and what we want is theta 2. So theta 1 is this half rotation here. Take away the beta. That is, you want halfway around, do this half rotation, but take away the beta. Well, half a rotation in radians is pi. Take away the related acute angle, pi over 6. So let's make them common denominator. Pi is the same as 6 pi out of 6. Take away pi out of 6. You get 5 pi out of 6. So that's the first answer. You can check on your calculator. If you are in radians and you go, what's the cos of 5 pi over 6? You'll get negative root 3 over 2. Let's calculate theta 2. That's going to be always the same in quadrant 3. Each quadrant has their own formula. In quadrant 2, it's 180 take away the beta. In quadrant 3, it's 180, or pi, plus the beta. So what's pi plus pi over 6? Well, that's just 6 pi over 6 plus pi over 6. I think I'll put a little arrow. I'm getting down the edge of the paper there. So theta 2 is just 7 pi over 6. And again, if you plug that in and you're in radians, cos of 7 pi over 6 is going to be the same as negative root 3 over 2. And we've solved using radians.